We are ready to now discuss a very hot topic in machine learning, which is deep learning. What is deep learning? Well, deep learning is a deep neural network. And where a deep neural network comes from is by taking this layering process of a neural network and building it on top of each other multiple times. So if you have a neural network, what you can do is you can take its output and stick it into another neural network. But you can keep on doing that. You can go sigma of sigma of sigma of sigma all the way down to x, where you'll keep on having these w's are not the same w's, right? You have a different one for each of these sigmas, but now you have a highly parameterized model which will be able to scrunch together your input in a bunch of different ways. And this right here is called a deep neural network. Deep neural network. And these deep neural networks are the mathematical model that gives us deep learning. So one question is, why do you think that repeating the same process will do anything, right? Why will this help? The reason why it helps comes from a pretty deep understanding of what neural nets are doing. So let me try to explain geometrically what a neural net is doing. So let's say our data flows on this line, right? Let's say we wanted to get a function that perfectly matches this line. Well, a linear function, it would only be able to draw lines, right? W times x plus b, this matrix multiplication, is only a linear function. So what it can do is it can say, let's take these axes and rotate them so that way we're in the middle. So after applying wx plus b, we've now rotated our frame of reference such that we're now going through our data points, but we're not matching it perfectly. When we then do this nonlinear change, what we do to it is we now allow ourselves to put a bump in there. So let's say we've now done a rotation and our data points mostly follow this line. We can now try to bump our axis so that way we match the data. And we bump it with a sigmoid. So we can say, oh, let's bump it once so that we match it with a sigmoid. And after this next rotation, in the axis that is corresponding to this perturbed line, our data against it now can be correct here, but is going to still be a little bit off. And you might think, well, what's the way that we fix this? Well, let's rotate again and bump it once more. Rotate it, bump it, rotate it, bump it. And if we keep on rotating and bumping, then our function will be going along the line that we want, that is our data. And then we just have to pick the point along our data which matches our data. So this process of repeatedly adding bumps is just the process of putting our data through this sigmoid function over and over and over. And that is the process of deep learning, right? This is the deep neural network and why it works so well. So no matter what nonlinearities our data has, no matter what kinds of lines they flow on in n-dimensional space, a deep neural network is able to learn that bump by repeatedly being able to put bumps wherever it needs to. It knows where to bump by choosing all these W's and B's that show up in the repeated neural network functions. So that is the mystery of deep learning. You need to know what learning is, like what is the learning process. You need to know the sigmoid function. You need to know a neuron, but once you have all that, you're just chaining a bunch of neurons together to give what we call these layers. Each one of these is a layer. And when you have a bunch of layers, that is a deep neural network. And training this type of architecture, training this model, is deep learning.